This is a demonstration of the 3D sketching journal software developed at Cornell University for tablet PC computers using the Microsoft Tablet PC API. Here, a user is using the application to sketch out a simple shape. The user simply draws the shape's lines with the pen and connects them in order to represent the shape's 3D geometry in 2 dimensions. Bad strokes can easily be erased using the Stroke Erase tool. Once the drawing is complete, the shape can be reconstructed by pushing the pen's barrel button, and the 3D geometry is recovered. The same interface that was used to create the shape can also be used to modify the geometry. In this case, the user is creating holes by sketching straight or curved strokes directly onto the object's faces. Here, the user is adding a complex hole to the object by sketching lines directly onto the object's faces. The Point Erase tool is then used to erase the line between them. The resulting vertices are then rejoined to create 2 new faces that define the hole. The Color tool can be used to change the color of each face. The Zoom tool can be used to magnify the object and add fine details. Curved strokes can also be included directly without having to be interpolated from an object's faces. In this case, the user is attempting to sketch a lunchbox type shape. The 3D journal application attempts to reconstruct the position of each curved stroke by using the object's features. One of the curved strokes has clearly been reconstructed incorrectly. The curved stroke can be deleted using the Stroke Deletion tool. The object is then rotated to a viewpoint that facilitates drawing the correct curve. Note that simple curved surfaces are then reconstructed automatically. The shape of a curved stroke affects the way that it is reconstructed. Note that in this case, 2 different curved strokes produce 2 very different results using the same axis system. The 3D journal software also incorporates physical analysis tools that can be used on the reconstructed shapes. Here, an L block is sketched out, reconstructed, and then subjected to physical analysis. First, the lower face of the block is anchored so that it will not move. Then, a load is applied to the top of the block. The direction and magnitude are indicated by the red arrows. The stiffness of the block's material is then set, and a displacement analysis is run. The effects of the force on the position of each vertex in the tetrahedral mesh created from the object are clearly visible both in terms of color and in terms of displacement. The strokes remain in their original positions. Here, the user modifies the L block by adding a tunnel from one side of the block to the other. The effects of adding this feature to the shape are readily observable using the physical analysis tools. In this instance, the finite element analysis will be used to examine which locations in the block are under high stress as a result of the load applied to the top of the block. High stress points are colored red and low stress points are colored blue. High stress points are clearly visible on the inner part of the tunnel and around the lower anchor points. If the simulation is rerun using a less stiff material, the increased deformation is clearly visible. Combining tablet PC-based sketch reconstruction with physical analysis tools allows for fast, iterative design of 3D shapes.